Welcome to Ames Public Library for How the Great Plains Waters Are Changing, a program brought to you through a partnership with Ames Public Library and Outdoor Alliance. I'm Megan. I'm the Adult Services Manager here at the library. We invite you to join us for future programs, which you can learn more about through our current issue of Page 1 or by signing up for our events email. I do have a couple of events highlight for you. This Saturday at 10 a.m. in this room, we have Lights Out Iowa, Saving Iowa's Birds and Pollinators. And Monday, March 23rd, we will welcome author Art Cullen to discuss his new book at 7 p.m., also in the auditorium. So I hope you can join us for one or both of those events. For your comfort and safety, if you need to step out of the room for any reason, please do so. Restrooms are right behind the welcome desk and emergency exits are to your right. For those of you joining us online, we'll be muting your microphones during the presentation, so please submit your comments online via the chat, and I'll be monitoring that chat to make sure that your questions get shared with our speaker at the appropriate time. If there are questions at the end, I'll come around with a microphone so that our friends on Zoom can hear you and your question. We are recording today's session, and it will be posted to Ames Public Library's YouTube channel after the program. If you get bumped out of the event on Zoom, just follow the original link and you can get right back in. At this point, I will invite Diane Burt of Outdoor Alliance up to the podium to do a brief presentation about Outdoor Alliance.
Thank you, Megan. Actually, I'm here to welcome you, and it's great seeing so many people. I hear there are a lot of things going on, so we're very pleased that you chose to come here. First, I'd like the board for the Outdoor Alliance to stand up so you can see who is here for our board. We have John Pullman, Greg Vitale, and Claire Andreessen. You're going to hear from Claire in a few minutes. We also have Linda Wild and Jim Colbert on our board. Linda may be. And key volunteers, we also have a few of them. I saw Cindy back there. She does a lot of our financial work. Anyone else that I've missed? Oh, and Jay, yes, thank you. And I'd like to introduce our person who's going to give the update for the Outdoor Alliance. This is Claire Andreessen. Claire is one of the newest members of the board. She is her prior life, I guess continuing life, is university professor of veterinary pathology at Iowa State. She's maybe emeritus, but she is failing at retirement. She was just telling me how many hours she is reading slides, not only here in Iowa, but so she will present the brief review of the last year, kind of a required part of our annual meeting. Use this one or that one.
Thank you, and welcome again to everyone. So I just wanted to give a brief overview. I am the newest member of the board of Outdoor Alliance and what we do, and just a brief overview of some of the projects that we have ongoing. So our mission is very closely tied to the presentation today because outdoor recreation, education, and conservation in Story County is a major focus that we have. So we partner with other like-minded organizations. So if anybody has suggestions for organizations that we can partner with, we're always very open to that. We are a 501c3 status, and our endowment and finances are with Story County Community Foundation. So, for example, there are the board of directors, but we have a lot of volunteers that also help, and volunteers are very welcome to engage. And Laura Besco is one of the volunteers that we had, and they are often involved in writing grants. So writing grants and obtaining funds, and this had Outdoor Alliance sponsor Walmart Spark Good and the Rotary Club of Ames contributed to the postcards of ways that you can help birds. So there were several aspects to this. Also bookmarks were created, and there's interactive artwork that was done to raise awareness about pollinators, and that's currently under development with Kimberly Moss for scientific illustrations. So we have funding from help and assist with funding from a variety of sources, but certainly volunteers. We're glad to have a broad range of expertise to help us out. Some of the things looking ahead, we focus on supporting Story County for conservation land acquisition and improvements, and once again, financial contributions and service projects. So we try to certainly bring awareness for those. Trouble hearing me in the back? Okay. So assistance in raising matching funds for projects, we assist with that as well, especially that was a bond issue that was very successful and funded by the Story County Water and Land Legacy. So that is ongoing, and those updates are given by Story County Conservation as far as the projects that are ongoing, and also to develop strategies to engage members in volunteer opportunities. So volunteer opportunities are certainly related to the mission, and we have Rummage Rampage, you may be familiar with. We partner in those activities. The Iowa Prairie Network annual meeting that's at the Ames High School, that is something else that we support and participate with. And also, anyone's welcome to come to our board meetings. And once again, we're always looking for volunteers, and especially to learn more about what we do. Ames Reads Leopold has been on KHOI radio, and so that is an event that we participate in. There are also numerous hikes. We have a website too, so be sure and check out the website with events and hikes in the spring, winter, and fall times of year. And it's great to be out and outdoors in the Story County Conservation Parks, and also our Cleaning Rivers projects. So upcoming events, like I said, the spring wildflower walks will be starting, and those are on our website listed. So April 23rd, 30th, and May 7th. And then the annual spring stream cleanup too is a big project that we assist and participate in as well. So thank you for your time. And like I said, be sure and check out our webpage for additional events and things that are going on as far as projects.
Thank you, Claire. It's now my pleasure to introduce our main event. If you have questions about the Outdoor Alliance, you've seen several of the board members stand up. Please catch us after the meeting. We'll try to hang out here for a little while. So our speaker is Amy Bergen. The title of her talk is Greener and Drier, How the Great Plains Waters Are Changing. She is chair of EEOB, and for those of you not in the thick of it at Iowa State, Department of Ecology, Evolution, and Organismal Biology. She received the 2025 Leadership Award from the Society for Freshwater Science. I think that's a big deal, too. Her PhD is in zoology and ecology, evolutionary biology and behavior from Michigan State University and Kellogg Biological Station. And her research program asks and answers fundamental and timely questions centered on understanding how human activities influence water quality of streams, rivers, lakes, and wetlands using interdisciplinary lens, integrating limnology, biogeochemistry, and microbial ecology. From her family, I heard that she's had a long interest in science. It's not always gone smoothly, though. Apparently at Cole College, they called in the DEA after one of her experiments. Something about methamphetamine. So if you have a question about that, you can ask Amy. So thank you, Amy, for coming, and I look forward to your talk.
Thank you for that introduction and for the invitation to come and share some thoughts today about how water in our region is changing. So I know that it's later at night, so I want to start with the end of the talk. The things I'm hoping to convince you of today as I go through this is that the Great Plains as a region is defined by extremes and variation, and that this environmental variation has led to some really cool aquatic ecosystems that are unique to this area. However, we have challenges, as I'll also discuss. A lot of human activities that are altering water in the region, and many of the changes that I'll discuss are likely going to be very difficult to reverse. My conclusion in all of this is that we all need to be in on these what we call wicked problems in environmental science. Science can't do it alone. We need community groups, we need agencies, we need lots of different perspectives and skills to be able to make any kind of progress to protect and understand the Great Plains aquatic ecosystems. So this was a word in my bio. I consider my subdiscipline limnology. Limnology is the study of inland waters. This is from the Association for the Sciences of Limnology and Oceanography. The definition is the study of lakes, reservoirs, rivers, streams, wetlands, groundwater as ecological systems that interact. It's a great Scrabble word to know. However, I'll generally refer to myself as an aquatic ecosystem ecologist as well. And I've worked for about 25 years in water. I got into water in part because I grew up in the state of Iowa, as I'll also discuss. When I'm having a really good day, this is what I get to do. Hang out in waders in a stream, usually trying to understand the chemistry of it. And then I take that data back and write papers. This is a word cloud from the 65 or so papers that I've authored or co-authored. A lot of work on nitrogen cycling in streams and rivers. And then kind of try to put it all together into what we call a research program. So I'm interested in how nitrogen moves around in a landscape and transforms, particularly in streams and rivers. I'm interested in how lakes that have a lot of nutrients in them, we call those highly eutrophic lakes, operate, and how they're different than what we think of as like naturally or lower nutrient lakes. And I'm also interested in wetlands and how those can be kidneys on the landscape. We often use the analogy to help clean up some of the water problems that we have. In reality, my days out in waders are very few and far between anymore, and I rely on a lot of students to help me get this kind of work done. And so this is maybe a more honest look at what a limnologist does. So we do a lot of fun. We are field scientists. We spend a lot of time outside playing in rivers and lakes. These are some of my students in Kansas measuring how much water is moving through the river. That is actually me in the kayak with a drone that we had helped develop to be able to sample water in these lakes. We do kind of crazy field experiments sometimes. These are giant, about 10,000 liter tanks where we were trying to manipulate the different microbes in them. This is one where we tried to dry out a whole stream. That's a whole talk in and of itself. We spend a lot of time filtering water to try to understand the chemical composition of it, as well as to take the microbes out and be able to study them. And then we also measure a lot of microbial processes. And so this talk that I'm giving started as a keynote talk for a smaller group of limnologists called the Great Plains Limnological Society. And I was invited to kind of give my perspective on water in the Great Plains to them. And I, having talked to my students, know that the Great Plains as a water society also suffers a little bit from what all Midwesterners suffer from, which is that the rest of the country just kind of thinks we're flyover, right? So we often kind of get, dismissed, ignored as not being very interesting water bodies because you've got, colleagues at different meetings showing us pictures like these that are not from Iowa, clearly. But, what I wanted to use this talk for was an opportunity to help our students understand the really cool things about water bodies in the Great Plains, what makes them unique, and as well as be open-eyed about some of the challenges that we're facing around water issues in the Great Plains, so that we can maybe circumvent some of this flyover country and help people understand that the Great Plains is a really great place to think about water and do limnology. Of course, anytime you're trying to be in a group and decide where is something, there's a conversation about what is the Great Plains. And so I have this to offer as a map from the Atlas of the Great Plains. These are, I think it was something like 25 different boundaries of where the Great Plains are. So there's 25 different circles up there. So Iowa is in the Great Plains a lot of times, but not all the time. There's clearly a strip down the middle there that tends to always be defined there, but it can be wide-ranging geographically. I'm going to land on this particular kind of definition of the Great Plains. This is from an atlas called Lakes and Wetlands of the Great Plains. And so this particular atlas has it going through over into eastern Montana, into western Minnesota, and then all the way down through most of Iowa through here, Nebraska, Kansas, the Dakotas, a good chunk of Oklahoma, parts of Colorado, Wyoming, and New Mexico, as well as a big chunk of Texas, even down into the coastal area. And as you can see from here, the definition, I think, from an environmental perspective of the Great Plains is that it is a region of extreme variation. We have a huge temperature gradient here. So this is the mean daily temperature going from Texas, an average of 24 degrees Celsius, up to Montana in more of like less than 1 degree Celsius. So huge variations in mean daily temperature. Bigger even variations in rainfall. So obviously going drier as you get farther west, but being relatively wet in the eastern part. Here in Iowa, we've received somewhere on the order of about 32 to 35 inches of rain a year would be the translation there. And in western Kansas, that can be as little as 18 inches of rain. So a huge variation in how much rain is in the region, largely on an east to west gradient here instead of a north to south, although there's some north to south variation. There's also a lot of variation in land cover. And we'll talk a lot more about this, but some of these states, particularly Iowa and the Great Plains, are highly developed, have been converted over from their original landscape, whereas other aspects of the Great Plains still have a lot of native landscape intact. That's true particularly for western parts of Colorado and Kansas, as well as up into the Dakotas. So a lot of variation, a lot of extremes. And we usually think of the Great Plains, right, looking like prairie and bison. However, I want to highlight the water in the Great Plains. We have some beautiful water bodies, including some natural wetlands. I'll talk a little bit about these in Kansas, the Cuivera National Wetlands. Beautiful groundwater rivers in places like Nebraska. This is the Loup River. And we also have just like really kind of, run-of-the-mill, basic, but still very beautiful water bodies. And a high degree of water bodies throughout the Great Plains, even though we aren't necessarily recognized as a very water-rich region. So this is another map from that same atlas showing the density of water bodies. So the darker colors mean that there's more frequent water, and then the very blue dots are large, so federal reservoirs for the most part. And again, this more or less tracks the precipitation variation, a lot more water in the eastern part of the Great Plains, and it becomes less available as you go further west, so fewer water bodies, but still a great extreme and variation. And I have spent my career in the Great Plains. So I've just been back at in Iowa for about a year now. I grew up here, as I'll discuss, but I spent prior to here 9 years at the University of Kansas, and then prior to that 5 years at the University of Nebraska. So I've spent a lot of time in this like little triangle of the Great Plains, thinking about water issues. But of course, I was born in Iowa, so I'm going to also spend a little bit more of a focused time here than I did when I did the original iteration of this talk. And Iowa, I like to say, is literally defined by water, right? The eastern and the western borders of Iowa are rivers. And so Iowa, if you're looking for the most prominent water feature in Iowa, I would argue that it is streams and rivers. And this is how water scientists often like to view the world, not necessarily in counties or in roads, but what are the waterways? So this is a map of third order streams. These are generally big enough streams that they have perennial flow. So they're flowing all the time, draining somewhere on the order of about 2,200 acres or 22,000 acres. So decently sized rivers. And I just love this map of Iowa. I always, it reminds me a lot of thinking of like veins in a body system, an organismal system. And in fact, for the type of limnologist I am, a stream ecologist, we often use the analogy of the stream being an integrator of what's going on in the landscape. So much like you would go to the doctor and take a blood sample and get a sense of like what kind of potential health issues you have, the type of work I do studying water quality can help us understand the health of the overall system, again, by taking a sample and understanding the chemical composition and how it's changing over time. And I would say that Iowa and its kind of connections to water were really what got me into my career. So as I mentioned, I grew up here. I have the photographic evidence for it. So if you recognize this guy with dark hair, you've been here a while too. And I grew up in a rural community, as I'll also discuss. I was an FFA. And when I was younger, an event that made a huge impact on me was the 93 flood, the Great Flood, as we called it, maybe still call it, although there's been a few more. And of course, that had huge ramifications for the city of Des Moines, took out the drinking water system. In fact, I often tell the story when I'm talking about this, that my dad used to have a can of water from this time, right? We didn't have plastic bottles of water then. And so the Anheuser-Busch company had canned water to distribute when the drinking water system was down. And that's something I've thought a lot about over my career. Of course, it hit Ames as well. So that's a picture of what Hilton looked like in the summer of '93. A lot of you probably also remember that. But this made a huge impression on me and really got me interested in water and thinking about what I could do in that area as a career and as an environmental interest. Of course, as I mentioned, I grew up in Iowa, and when I went to college, I started getting opportunities to be able to do studies of water, including the one mentioned that was busted as a drug lab. That is a true story, but I still got into grad school. And so I think about as a ecosystem ecologist change and how the landscape has changed a lot. And when I'm thinking about it in Iowa, I think about it in a different sense, in part because I have a generational attachment to the state of Iowa. And so I want to talk a little bit about how the composition of Iowa has changed over time in terms of its landscape and what ramifications that has had for some of the water issues that we face today. So when my great-great-grandmother was born in Warren County in 1850, Iowa had 23 million acres of prairie and about 5 million acres of wetland. And 8 years later, Iowa State was chartered. And then in the 1870s, we were largely doing agriculture with horse-drawn plows. This was when my great-grandfather was born, second generation Iowan. This period in the early 1900s had a lot of agricultural developments that have implications for water quality. Clay tile drains, which I'll show you some pictures of later, were developed. Hybrid corn company was developed. Gas-powered tractors also became available. And it was around that time that my grandfather was born in 1918. By the 1950s, commercialized fertilizers became available. So this is when we started seeing a lot more nitrogen available to use for fertilizer. And that's about when my mom was born. I didn't put a year on a mom. And by the time I was born in the 70s, we didn't just have these fertilizers that are naturally occurring but could be synthesized. We had wholly new chemicals that had been developed, like glyphosate, that became available in the 70s. And of course, now we've had all of these agricultural changes to the state that have dramatically changed the composition of the landscape. So now we have a state with about 1.4% total wetland wetland coverage, less than 1% prairie coverage, and 85% agriculture. And if you were to put it in terms of acres, there's an estimated 30,000 acres of native prairie left in the state and about 640,000 acres of wetlands. So massive changes to the state just in the span of really 3 generations of my family's lifetime here. And I think that that's really important to remember because, this is a lot of change very, very quickly. And it's going to be hard to undo some of that change when we're talking about some of the water quality implications of that change. Of course, we have change not just in the composition of the land use, but we also have change in terms of the agriculture. So when my great-grandfather was farming in the early 1900s, he had a somewhat diversified corn cropping system. Corn quickly became dominant in Iowa and has been ever since, but he also would have farmed oats and wheat and the family operation. By the time my grandfather had taken over in the 40s or so, 40s and 50s, that would have been similar, but soybeans, the green line there, are starting to take off as a new kind of commodity crop. And by the time my aunt and uncle took over the family farm in the 80s, we had largely switched over into the landscape that we know today, which is largely a soy and corn rotation. Of course, this was also, these changes in what we were able to grow was also brought on by the advent of these kind of chemical fertilizers. So this is another time series starting in 1950 showing how much nitrogen fertilizer consumption and use was available. This is for the national kind of scale, but you can imagine it also being true in Iowa. We just had an explosion of the use of fertilizers in the late 50s and 60s. In fact, I remember having a conversation with my grandfather before I went to graduate school at Michigan State, explaining to him that I was going to go and try to figure out how streams and rivers could remove nitrogen and help clean up Iowa's water issues. And he was telling me about remembering when they came on the scene to be able to use for agriculture and wondering himself, like, where would they all go? So I found that to be like a really interesting full circle. Of course, change is the only constant, and we are still undergoing change. The big thing that's changing right now is our climate. I really like this interactive if you haven't played with it. This is from the New York Times. And so it has the ability to kind of drill down and figure out how specific areas of the United States are going to experience climate change. And when I look at this as a water scientist, a person who thinks mostly in terms of that, I see a lot of connections to water. While we mostly think of climate change as heat related, of course, that's connected to the water cycle. And what that's doing is amplifying some extremes in events that we're experiencing. So we're experiencing intense droughts. That's going to be amplified in kind of much of the Great Plains, but we're also experiencing extreme rainfall. That's part of what we're starting to see, big storms presenting in Iowa, powerful hurricanes in coastal regions, sea level rise. There are huge water connections to how we're all experiencing climate change. When we drill down to thinking about how climate change is impacting Iowa, we're feeling it in terms of the temperature, not in the summer. There's a differential in terms of how different seasons are warming. Winter and fall are warming faster than spring and summer. And so we're already seeing evidence of this. This is ice cover duration. Limnologists take data on anything. And so this is a long-term record of how many days ice has covered Spirit Lake. And you can see that the red line there declines over the past, 70 years or so. So there's a measurable decrease in the number of ice-covered days on many lakes around the world, really. The longest running record of this kind is from Japan. It's about 500 years old, which is a really impressive data set. The other way we're experiencing climate change in Iowa is through increases in spring precipitation. So this is a map of the United States showing an increase in spring precipitation. Ours is supposed to increase more than 15%. And we are seeing that in data where we're seeing an increase in days with more than 1 inch of rain, not just in the spring, but in general, we're seeing bigger rain events as well as those kind of drawn out by longer dry periods. And so climate change, landscape change, all of this is change embedded in a landscape that already has a lot of variation in it. So it can be hard to kind of pull out what are the important variables to understand why aquatic ecosystems are behaving the way they are. So now I'd like to, having that background of change, take you on a short tour through some of the Great Plains water features. So I'll break that as we do into the lakes that we study. We tend to have a lot of big reservoirs like this one, wetlands that are unique to the Great Plains region, and the streams and rivers that are here as well. So I'll start with the Great Plains lakes. Most people think of lakes in the Great Plains as kind of boring and maybe not very pretty. I want to highlight that there are some really unique, esoteric kinds of lakes in the Great Plains. So these are from some areas of Kansas. This is the Quivira Wildlife Refuge, National Wildlife Refuge. And these are salty lakes. Many people are surprised to find that we have saline lakes in the Great Plains, sometimes saltier than the ocean itself. And that is in part due to the geology and the hydrology of these places. But that can mean that we have really unique plant communities that develop that are endemic to those places. And they also tend to be very important areas of other types of biodiversity. So you can kind of see some of the salt flats in this kind of lake wetlandy complex through Quivira. Another unique kind of lake in the Great Plains are what are called the sandhill lakes. If you've ever driven through western Nebraska, maybe you've seen sand dunes from the interstate. You have to go a little bit north of 80 to really see them. But what has happened there is the aquifer, the Ogallala aquifer, has come into contact with the groundwater is basically intersecting with these sand dunes, creating these pockets of lakes that look really cool from a satellite image. So these are the little lakes that kind of form in between the sand dunes. This is what they look like on the ground. These have kind of isolated into having really distinct chemistries. Some of them can be super alkaline, very basic lakes. Some of them can have really distinct microbial communities in them. They're often very clear water lakes because these are not embedded in the high amount of agriculture that we often associate with the Great Plains, but a lot of really unique types of lakes that have varying degrees of chemistry differences. What we often associate with lakes in the Great Plains are what limnologists would call artificial or human-made lakes. We have a number of farm ponds, including one on my dad's property that we often discuss about how could maybe look a little bit differently. But we have a high density, again, tracking where there's a lot of precipitation in the eastern part of the Great Plains, and then becoming less common as you go out to the western part. There's also lakes that have been formed for different reasons. When interstates were built across this area of the U.S., oftentimes the landscape had to be modified. So in Nebraska, for example, a lot of sand had to be dug out in order to have a flat area to have the interstate. So there are a lot of lakes that they call borrow lakes or pit lakes. These would be similar to like a quarry lake, but it's a sandy lake bottom. And they have some really interesting kind of shoreline development, right? Because basically the excavator sat here and dug all the way around it and then created this very funky looking lake. But they're really unique and kind of a nice lake for this region because they aren't as embedded in a lot of agriculture, and they tend to be some of the clearer water lakes that we have in this area. The main thing we associate with lakes here are federal reservoirs, very large reservoirs, right? So here's the picture of Saylorville, and these have exploded, especially over the Great Plains. So this is a little bit hard to see, but right through here is the stack of states of the Great Plains, and the height of this bar relates to how much water that reservoir holds. So you can see as you go out into the western part of the Great Plains, you have some huge reservoirs. And this is because water is relatively scarce. When they get rain, they catch it and hold it and use it for irrigation, for flood control, all of those various things. But there's, as you move into the eastern part of the area of the Great Plains, a lot of smaller but still abundant reservoirs. Lakes throughout the Great Plains, much like the rest of the country, are changing as a result of human activities. One of the main changes that we see occurring is what limnologists call eutrophication. So this occurs when you have a lot more nutrients in the landscape than were there previously. And so that can fuel a lot of growth in the water and turning it green. So this is a picture actually from Ohio, where I also used to work, of a person jet skiing in very green water as a result of a lake that became highly eutrophic. This can become very problematic in terms of developing additional problems with what we call harmful algal blooms or cyanobacterial blooms. So this is, again, a picture from that same lake, it turns out, in Ohio, but we also have this happen in the Great Plains. A notice of a no contact order with this lake because of high toxin production. When you get a certain kind of cyanobacteria that can bloom, we say, in this, it can produce toxins that can be harmful to humans as well as to other animals. And then the other way that our lakes are changing is because we have so many of these big federal reservoirs, and they tend to be situated in areas where there's highly mobile sediment. We have a lot of sediment move into the reservoirs, creating what we call sedimentation. That means that we lose how much volume we can store in a given reservoir. So this is a reservoir in Kansas called Tuttle Creek. When Tuttle Creek was opened, shortly after it opened, the reservoir's depth extended all the way up here, and just 5 decades later, it had lost about half of its length in terms of water holding capacity due to how much sedimentation had occurred. This is an extreme example, but this is something Kansas cares a lot about. So you can see there's a lot of reservoirs there, and the blue line refers to how much water they can hold, and then the brown part of that line refers to how much has been sedimented in. And of course, this is an issue that's going to be exacerbated with climate change. As you have bigger storms that can carry more sediment into it, you're going to have a lot more sedimentation occur. So I'd like to switch gears now from talking about lakes to talking about wetlands in the Great Plains. And I'm going to talk about 2 distinct types of wetlands that we have here. The first are called the potholes, the prairie potholes you're probably familiar with. And the second are called the playas. And they have some similarities, but also some distinctiveness. So the first I want to discuss is those of the potholes, the prairie potholes. The prairie pothole region is extensive, right? It comes down into this area of Iowa that we call the Des Moines lobe, and extends all the way up through the Dakotas and into Canada. This is what it looks like aerially, and currently, especially in this region, very little of the area is covered in wetland. But historically, there was substantial wetlands in this region. Iowa has lost 99% of the wetlands that historically existed in the Des Moines lobe, and that's in comparison to 89% of the wetlands overall. And I contrast that then with this type of wetland called a playa. Sometimes these are called lakes. There's a debate about whether they're lakes or wetlands, but they're shallow water bodies that exist through the western part of the Great Plains for the most part. And these are created by kind of groundwater pockets that come up and interact with the land surface. So they can be incredibly abundant through areas like the panhandle of Texas, up into Kansas, and into Nebraska. Of course, these wetlands were formerly more extensive, and this is possibly one of the bigger parts of change in the state of Iowa. So the reason we have fewer wetlands in the pothole region, a big reason, is because of something called tiling, which is probably a practice that you're familiar with, but it's been around for a very long time, which isn't always appreciated. So Iowa has, as you can see on this map, some of the highest tile drainage density of the Midwestern United States. So this area, especially in the Des Moines lobe, has a very high probability of being tile drained. And this tile drainage has occurred for over a century at this point, right? This is a picture of old tiles. They're called tile because it's clay tiles that used to be hand laid in 18-inch sections. So this was incredibly laborious work, digging ditches, laying the tile down so that water could be flowing out and drain the wetland to be arable for agriculture. In fact, this one has a date of 1885 on it. This is from the Iowa Water Center website, and it says, "We, the men who started the tile," right? So this was indicative of just how long tiling has been occurring in this region. And as I said, when you lay that tile down, this is what it looks like today as an outlet. You lower the water table, and that can be good for growing things. Corn is not an aquatic plant, so it does not want to be in a wetland, but that has also meant the destruction of a lot of the wetlands in the pothole region. That also, the flip side to that is that there's been an increased interest in wetland restoration and wetland creation as a result of recognizing their importance around water quality issues in particular. So this is a map that shows areas of very high restoration potential for wetlands in the United States. And you can see the Des Moines lobe very clearly in Iowa there. Very high potential for wetland restoration in our region, as well as throughout other regions that wetlands have been removed from for other reasons. And there's been a concerted effort to increase the number of wetlands through many different kinds of state and federal programs, again, as a way to try to address some of the water quality issues that we face. But again, we had on the order of 5 million original acres of wetlands. So this is really just not quite going to get the work done compared to what we had originally. Wetlands in the Playa region are changing for different water-related reasons. There, the issue is not draining water off of the landscape, but rather pumping water from the ground to put onto the landscape. So as you fly over the Great Plains, you see these things from the air, right? Crop circles. These are created by center pivots. And this is what a center pivot looks like on the ground. There's a center point to it that has a well underneath it, and it moves water in a circle around, and that alleviates the precipitation limitation to how much they can grow in that region. And so here you can see the extent of the High Plains Ogallala Aquifer and areas where there have been substantial declines in the amount of water in the aquifer. In areas, these kinds of irrigation systems can be particularly dense in some areas. So this is an area of Nebraska that I'm showing now, which is has wells on the order of 4 to 16 to even more than 16 wells per square mile. So very densely packed. This follows the bend in the Platte River here. So this is a relatively shallow area to be able to have a lot of irrigation wells. It also overlaps substantially. This is a little bit light, but you can see these playa wetlands that exist again along this bend in the Platte River that historically had been far more extensive than they are today. You can see just by the difference in the type of black dots there. So the groundwater pumping has meant that there's a lower water table and not as many of these wetlands abundant as available. And that has huge implications for migratory waterfowl, for lots of different other kinds of aquatic organisms. Again, the landscape change due to an environmental factor related to human use and need and dependency on water. The last type of system I want to discuss are maybe my favorite, streams and wetlands, rivers and streams. I like them all. In the Great Plains, we have rivers that are highly dependent on this groundwater that I was mentioning, that our wetlands and lakes are also connected to. And how stable the groundwater is really determines what we say the hydrology of the stream. So that we have some beautiful rivers. If you've never been to western Nebraska to see the Niobrara River, it's an amazing, gorgeous river to be able to float on. And it's a very stable river. So my husband Terry and I actually floated on this river in 2012 in the height of the drought, right? The epic drought. And it was lots of other rivers. I'll show a picture of one were completely dry, but this one still had enough water that we could canoe down it and had amazing kind of groundwater stability. I'll contrast that with a site that I work on a lot in Kansas. This is at the Konza Prairie Biological Station. This is a system that we've worked in for about 5 years now. These are 2 pictures that I took about 10 days apart. And so I have my sensors hanging out here, waiting for the river to come. And we got a storm event, and then it's like you flip a switch and it becomes a stream for a period of time. And we call these intermittently flowing streams. So sometimes during the year, generally during the spring, there's a lot of water in them, and then they dry out for other periods of time until you get a big rain event, and then they turn back on. So drying and flowing kind of dynamics are fundamental to how these streams behave, are part of the natural condition of them. Although we don't generally think of studying streams that go dry, they are incredibly abundant. So again, those are the pictures of Kings Creek that I was just showing you. This is where Kings Creek is in Kansas. So it's in the kind of eastern part of Kansas, really. And what this map is depicting is the number of stream miles, or the coverage of miles, that are classified as either intermittently flowing, turning on and off. Those are in the kind of like light green, or the stream miles that are classified as permanently flowing or perennial, and those are in the blue. And so as you can see in Kansas, we have a lot of intermittently flowing streams, and they become more common as you move out farther west where there's less water available. And we think of this as being something it's kind of the rule, not the exception, in a place like Kansas, but do they really exist elsewhere? And in reality, they are everywhere. So this is a map from the EPA showing the abundance of these intermittent streams by density. So I've got Kansas kind of highlighted here in blue, but you can see even in places like Iowa, even in very water-rich places like Alabama and the coast, there are intermittently flowing streams on the order of 30, 40, 50% even of the stream miles classified. So these are highly abundant systems that we know relatively little about, because aquatic scientists have avoided them when they don't have water in them, maybe understandably. But these are streams that are becoming increasingly understood to contribute to water quality improvements, as well as to what ends up going downstream. However, in studying these, we don't have a lot of data. This has been a real limitation. So the way we often study streams in the US is with a federal agency called the USGS. If you've ever driven over a bridge and seen this kind of like weird little top hat thing in a box next to it, you've likely encountered a gauge. We have over 9,000 of these gauges around the US. Each of these little dots back here is a gauge. Of all of those gauges, only about 540 or so are on what we would say non-perennial or intermittently flowing systems. And when we look at where those are within a state, even in a state like Kansas, where over 80% of our stream miles are classified as intermittently flowing, only somewhere around 4% of our USGS gauges are on them. So we just haven't even had the infrastructure to really understand when these streams turn on and off hydrologically, and how they're possibly contributing to downstream stuff. So this is an area that we're starting to think a lot about in the discipline of stream ecology. Of course, our streams are also changing in the Great Plains, again, because of humans and their dependence on water. So this is another picture of Kansas showing, again, perennially flowing streams in blue here. These were perennial between 1961 and 2009. And then this is a formerly perennial stream in red here that was perennial but is not in 2009. And so you can see here, this is in Kansas, they call this the Arkansas River. We would call it the Arkansas River. When I was at a water conference in Kansas, my first couple of years there, I worked a lot with a watershed organization I'll discuss here in a little bit, but the water keeper pulled me aside and she's like, you got to stop calling it the Arkansas River. They know you're not from here. And so I just called it the Ark. So this is the Ark, and at these 2 different gauges, you can see the amount of water that's flowing in Dodge City downstream of where Coolidge was. shifted over time, and it really bottomed out in about the 1970s. And that's when the density of irrigation, these center pivot irrigations, really picked up here. So this kind of massive hydrologic change in the landscape is not just affecting whether wetlands are there, but also how long and if streams have water in them. That isn't just true in places like Kansas. This is an image showing where water quantity is changing. So as this dot gets darker, red, that means that that stream is becoming drier. And you can see through much of the Great Plains, these dots where we do have data are indicating that our streams are having more days of no flow. And this is what it looks like when you're encountering a river. This is a picture I snapped, again, going out to Valentine, Nebraska in 2012 at the height of the drought. This is the Platte River. The joke about the Platte River is that it's a mile wide and an inch deep. There was no water in the Platte River, which was staggering as an aquatic person, right? To think about what had been there but was no longer, and what would happen when the water returned. So we have water quantity issues that we're dealing with in our streams and rivers of the Great Plains. We also, as we are probably all aware in this room, have a lot of water quality issues. Those are particularly heightened in places like Iowa, where there's a high degree of agricultural activity concentrated. So this is from a report I'll show at the end here, but that Polk County commissioned about water in the Raccoon and Des Moines Basin. But this is some of the only data that I can really find about nitrate concentrations back in historic kind of records. So this goes back to 1930s, before we had commercially available synthetic fertilizer. And you can see right about when that became available in the 1960s as the nitrate concentrations at the Des Moines drinking water plant increased. Now, this is in the finished water. That means the water that's being delivered out of the plant. So, of course, it is under the threshold of 10. But the increase in nitrate concentrations in about this decade is really dramatic. You can just imagine how much more fertilizer was going into the landscape then to cause this kind of a change. And Iowa has some of the highest nitrate concentrations in our streams and rivers of anywhere in the nation. And so this is another image from that report showing nitrate average concentrations from places where we have like long-term data. And you can see Iowa kind of lit up here in some of the highest concentrations. And so trying to kind of synthesize it, wrap it all up here, the Great Plains, we've got it all. We've got lakes that are salty and fresh. We've got lakes that are really oligotrophic and hyper eutrophic, many nutrients, natural and artificial. We have wetland legacy in our landscape, which means we have a lot of potential to restore them. We have streams that span a huge gradient of temperature, flow regime, use. All of this is embedded in a landscape of intense land use changes, management, priorities that are shifting, and increasing pressure on water resources. Oh, and changing climate, we can't ever forget that. And so the Great Plains is really a land of great variation and great change. And if we're trying to understand how things respond to variation that's increasing with climate change, the Great Plains is a really great place to start because change is baked into the place. I wanted to end too talking a little bit about Iowa-specific water issues. So I just did a quick search and was like, what's in the news related to water in Iowa right now? And was kind of surprised, but not terribly, about how many headlines I could pick up on just a very simple Google search just in the last couple of weeks. So the state has released what's called the Impaired Waters List. This is a list that's updated every 2 years. This year, there's more than 700 water, streams, wetlands sections listed on it. And that means that it has some kind of impairment for a specific kind of use that is beneficial to humans. There's also increasing concern in Iowa that's been verified through polling about water quality and how it might be contributing to health. I have to say, as I've moved back to Iowa after being away for a while, I've been really surprised at how much I've heard this piece of the conversation questioning connections between our environment and some of the health outcomes that are problematic in the state, including high rates of cancer. We also have environmental groups that are getting into the game over the impaired waters list in Iowa. Lots of news about the nitrate concentrations in the city of Des Moines and how that is operating even during the nitrate removal systems operating even during the winter, which is really dramatic. Increasingly, I think you're going to hear things about groundwater in Iowa. We don't typically talk much about groundwater here like we do in Kansas or Nebraska. But as we have these data centers that have become very abundant, or increasingly so, they're putting a lot of demand on our water resources. Hearing a lot about this in eastern Iowa, especially where these data centers are being pointed to as a cause of concern of having enough water in the groundwater or depleting groundwater resources. And then this is another water-related news, right? I didn't know this existed even after growing up here, but Clear Lake has a kite festival every winter on the lake. Lakes are great places to fly kites, but not if the ice isn't safe. And so they had to cancel it this year due to concerns about thin ice. And so I recognize this is a bummer. This is all of this is related to what we again call in the environmental world a wicked problem, and we can define that a few different ways. But it's basically a complex societal problem that has connected to so many other things that it's really difficult to see a path forward or a path out. They tend to be super persistent over time. There's no quick fixes. There's numerous variables that are interacting. Lots of conflicting values and diverse perspectives. All of the water issues that I articulated are wicked problems. In fact, some of society's biggest problems are wicked problems. These are the UN Sustainable Development Goals. So they have 17 goals here, and I would say each of these is its own wicked problem. It's things like poverty, hunger. What was striking to me as an aquatic person when I encountered this was just how many of the wicked problems are related to water. I count 5, but there's probably more up there are connected to water somehow. And so I point this out in part because it's not just like we have the issues in Iowa to deal with. We are all well aware of them, but these are fairly universal and require, I think, diverse thinking, diverse skills, and diverse people. No one person can tackle any of these things alone. And so these really require a lot of cooperation and engagement. And different thinking about how we train. So as a scientist, I've had the privilege of training a bunch of different students. This is the faces that go with the names on my CV, over 50 undergraduates, 10 graduate students, 6 postdocs. And they have all pushed me in various ways to think about the problems that we're all interested in different ways. I had the privilege of working closely in Kansas with a tribal college that was also in our town and trained 5 Native American students, and working with them really taught me to think about the history of the landscape in a very different way than what I had been trained to as a scientist or brought up to. I've worked with people that think about what's happening in the land in a different manner and how to manage it using fire instead of agricultural inputs. Lots of different variation, and I think training diverse people helps us bring new ideas to the table. Of course, you have to start them early. These are our kids helping out on an experiment. So getting them into the water and into the wild, I think, is also really important. I've also been privileged to have a lot of various funding sources and partnerships. And this is where I think nonprofits like yours really play an important role. Some of the best kind of partnerships I had were with a group called Friends of the Caw, which is our was the Kansas River watershed group for a river that drained about half of the state of Kansas. But not just working with them, I've also worked with different conservation groups and also with large collaborative teams. None of these environmental problems, again, are solvable by one person, but take a diverse kind of perspective and skill set and a way to look at the world. And that's one of my favorite things about working with groups like yours. So this is a little bit of more of a deep dive of the Kansas River group. I was on the board of that group for 9 years and met some amazing people through it. The people that are volunteers on boards of directors are just doing so much with their time and giving so much back. One of the people that I had the privilege to work with there was Lisa Grossman, who is an artist in Lawrence, and her subject is the Kansas River. And so she painted these beautiful, huge oil paintings of the Kansas River. And I look at this and I think Lisa is a limnologist. She really sees the river the way that I do, the way that water plays into the landscape, the way that sand is moving around due to the hydrology. And so, you know, she would not consider herself a scientist, but I think I learned a lot from her and vice versa. So having these kind of diverse groups of people really help us broaden our perspectives of how to see systems as well as how change can occur. And so I want to end a little bit there with some promising signs I see for Iowa water. I see groups like this, like IKES, the Isaac Walton League, getting into the water monitoring business when it doesn't become viable for water monitoring to occur through other sources of funding. Environmental groups can step in and help out with that. And not surprisingly, they're reporting that Iowans are very interested in knowing what's in the nitrate is in their water. Of course, this was mentioned as an important thing in our county. I was so impressed when I moved here and learned that this was going to be one of the first bond issues that we encountered, and that it had passed by such a high margin, 77.75%. Groups that are working on all of these different restorations are really important too for helping improve the landscape. And then the report that I mentioned from Polk County is this one. It's about over 200 pages, but it's a great analysis of all of the different changes that have occurred in water throughout the Raccoon, mostly river in Des Moines, but has a lot of information in it. And it's impressive to me because a county is leading the way in terms of really pushing for the synthesis of the science to understand where the problems are and how they can try to address them. And so with that, I'll circle back to my take homes. I hope I've convinced you the Great Plains is extremely variable, that variation has had some cool aquatic ecosystems in it, but that we do have a lot of problems related to human activities, and many of the changes that we have cataloged will be very difficult to reverse. Having any chance at reversing those and improving the quality of our water and how much water we have in our landscape really comes down to collaboration, again, between community groups and between scientists, agencies, everybody in to help understand, protect, and preserve these kinds of unique systems. So hopefully I have a little bit of time for questions, and I'll leave you with a pretty shot of the Kansas River.
Thank you, Amy. That was fantastic. I'll get the first question in. Others get ready, get your hands up. Do you have needs for volunteers for some of your research? And would a group like the Outdoor Alliance, you know, be able to partner with you somehow to get volunteers?
I would love to partner somehow. I don't have a lot of specifics yet. I've only been back about a year, and part of that year has been undertaking a more administrative role. So I have not had as much time in waiters as I have previously, but I am hoping to do a lot more work in the very near future and would love to partner with groups like this.
Not so much a question, but a comment. I was down at that presentation at Drake University when the report came out.
Oh, yeah.
There were 600 people crowding the auditorium. There were another 700 people online, and since that report came out, another 3,000 people have downloaded the report, and many other thousands, because of presentations across the state, have been reached as well. I'm not sure how many of the people who've downloaded it are legislators,
Yeah.
but they ought to be, because they seem to be paying absolutely no attention to the concerns of Iowa citizens about cancer, about water, about any potential connections, et cetera, et cetera. What do you see as a solution to, as a coming in from the outside, but an Iowan with an interest in what happens to Iowa? What do you see as some of the potential solutions to the problems that we're seeing?
That's a big question. On the political landscape, I'm assuming you're also indicating that's in need of a solution. I think that's where nonprofit groups can really move the needle. A big piece of what we did with Friends of the Claw was advocacy for water-related issues at the State House. And so part of the executive director's job was to go to the legislature and to lobby. And she was very good at coalition building. She was is a pretty unique individual to be able to help bring people together around really tough topics. So I think the nonprofits have a very big role to play in helping the state political system understand why everyday people in Iowa care about these things and trying to get it on their radar. It can be challenging in different kinds of other areas. You know, state agencies might have challenges associated with what they're able to really do in the purview of their positions. So I think it's got to come down to groups that have the flexibility to be able to, speak freely. In terms of like the technical solutions, we know really what a lot of the problems are. They're very well documented. A lot of what the issue is it comes down to differences in values and differences in incentivization, right? There's like very little public land in Iowa. So there's a lot of land in private ownership. So a lot of decisions are made by individuals, not necessarily with all the same information and values and whatnot. And so I think a lot of our challenges really come down to kind of societal and political conversations and education that needs to happen. Science always needs to have a seat at the table. But, we know wetlands are good. We know reducing nitrogen application helps. All of these things are kind of known entities. It requires more than just the science, I guess I'm saying.
More questions?
Hi. Did I hear Claire say you're a co-college grad?
I am.
We are going to have lunch.
Great.
I'm a librarian at the university.
Wonderful. Hi.
So I'm curious about you just, and this is just strictly curiosity. You mentioned how hard it is to restore wetlands and implying that it's hard to get those tiles out.
Yeah, there's a lot of them.
Okay. Can you describe some place that actually did it and just in high level detail?
Sure. There's a number of demonstration wetlands in and around Iowa State. There's a program called the CREP. I can't remember what it stands for right now. I apologize.
Conservation Reserve Enhancement Program.
Thank you. I'm still getting my Iowa State acronym library down. There's a number of these CREP wetlands around the state that some have become more of a demonstration. And so lots of local examples. That said, the tile drainage issue is a real big one. I don't even know the estimate of it, but it has to be in the hundreds of thousands of miles of underground tile. And I think of this as like a below ground stream network, right? Like it's just, it's going to be a really big thing to try to untangle.
Okay, I'm going to extend that one a little bit, Amy. Get rid of the tile, but now that's flowing into a stream that's been altered.
Yeah.
How big of a problem, even if you get rid of the tile, how much is going to remain because of the engineered streams? Yeah.
So what you're, I think, referencing is that we've straightened a lot of our streams. Sometimes this is called improvement. And so when you straighten a stream, you take out its natural features that can slow the water down. We call these meanders or bends that allow the water to kind of interact more with the subsurface, which is where a lot of the microbes live that can help improve water quality. So it's certainly not, there are no silver bullets, and I don't want to give that impression in any way here. So yeah, it's not just removing the tile, it's not just altering how much nitrogen's on the landscape, apply applied to the landscape. It's also, you know, restoring some of the native kind of properties to the systems as they occurred. But this level of change would be massive for a state that has changed as much as Iowa has. By some estimates, Iowa is one of the landscapes that has changed the most in terms of not resembling its original kind of properties. Going to take a lot.
Okay, other questions? Jim Peace has one more.
Story County has just restored.
So that the,
Yeah, okay. Story County has just restored, or completed the first project that resulted from the Water and Land Legacy bond that was passed last year. And these are some riverine oxbow wetlands up by the Wicks Wildlife Area up by Story City. So the first project is done and more to come. So and more wetland restorations coming as well. So
I got to start. Yep, absolutely.
okay, last chance. Oh. Well, maybe not last chance. Getting close.
Could you say a little bit more about your research with nitrogen cycling in the rivers and is this denitrification in the stream bed and
Yep, that's one of the things I study. Yeah. So I study the microbial processes that can remove nitrogen. One of them is denitrification, and try to understand how nitrogen gets into a river or a stream, and then what changes as it moves through the stream. So sometimes that's just trying to know how much is coming in, and sometimes that's trying to measure a whole process in a section to see how it's being transformed from one form to another. So yeah, lots of, I could talk for hours.
Okay.
Diane?
Yes.
I got a quick one. No, it won't be quick. I'm really glad that you brought your family with you. I think that's really
So many family members.
really kind of special, but I really enjoy the idea that you have some younger
Yeah.
members of the family here with you. And my question really goes to, what efforts do you see that the university, education programs throughout the state, what can we do to get them to have more of that age group be enthused about what you're talking about?
Well, my niece is not here. But I have to say, I was impressed when I was interviewing and coming up here, because I think what was May in 6th grade, 7th grade, I can't remember at this point. She was doing a homework lesson at home when I was staying with them when I was interviewing or something on the nitrogen cycle. And she was doing some pretty intense kind of, I thought it was very high level kind of homework that I think had been some kind of collaboration between the school district and the university in terms of developing that lesson plan. My kids aren't old enough yet, so I haven't encountered it again. But I do think that there are programs that exist. So there's the Iowa Nutrient Reduction Center. I was just at their roundtable today, listening to scientists and other stakeholders from across the state, trying to articulate what we think are some of the big questions that still remain about why we don't or can't predict, or how much nitrogen and phosphorus are being lost, and how we can hold more of those on the field. So I guess I'm saying I think there are a lot of ways for people at the university to connect with the community. There's examples of that in the school system, but there can always be more of that kind of thing. Sometimes it just comes down to capacity and funding from the university's perspective as well. We have a lot on our plates, but certainly is the kind of thing that I feel passionately about trying to get my kids out for.
Well, thank you, Amy.
Thank you.
Thank you for a wonderful audience.